First of all, thank you everyone for coming. This is amazing. I'm very happy to see all of you here today, especially because Stefan told me that no one was going to show up to my talk. So this feels very good. Thank you, everyone. Hey, Matt, good to see you. We're here today to talk about high-performance microservices with Ratpack and Spring Boot. Who here has heard of Spring Boot? All right. For the video, that was everyone. I'd be very surprised if you were at this particular Spring conference and hadn't heard of Spring Boot. It's a very big topic. Who here has heard of Ratpack? Oh, this is really great. This is fantastic. Awesome. So this will go very well. If it's your first time seeing Ratpack, feel free to come up, ask questions, get with it, play around with it a little bit. It's a very fun web framework to write code in. I'm going to cover a lot of the reasons why it's so fun and why it's so wonderful. And hopefully that'll set you on the right foot. So a little about me, because I love to talk about this subject more than anything myself. I work for a company called TimShell. And at TimShell, we have a mission to help empower nonprofits by providing them with a technology engagement platform for little or no cost to them. It's a really great company to work for. We really, I feel, bring a lot to the clients that we have, which is growing in numbers every single day. It's great work. In particular, I work on the cloud and DevOps tooling, where I use Ratpack. I've been fortunate enough to be able to use Ratpack for the last year and a half in production. It's been phenomenal. Feel free to talk to me about cloud and DevOps stuff as well. I know a thing or two, and always happy to talk about that as well. I'm the author of the O'Reilly book, which was just very recently published, entitled Learning Ratpack. This is effectively the definitive guide, the complete detailed resource of everything that goes into Ratpack, what it takes to build applications. Pretty much everything that we're going to cover today is covered in the book. With the exception of some of these code examples are really going to be geared more toward the high performance aspects of that. Who was here for the keynote this morning? So the keynote was fantastic, and one of the things that I really liked most about it was the fact that they talked about diversity in the technology industry and the things that we can do as a technology community to bring more diversity and bring more inclusion to groups who otherwise wouldn't have been empowered to do that. As part of writing this book, this is the first ever book on Ratpack. Ratpack has been an open source project for about 6 or 7 years. It's undergone a lot of transformations. We've been very privileged to have an extremely active community over the years that's stuck with us as we were figuring out some of these harder problems of building web frameworks. So having the opportunity to write the first book on it was something that I wanted to use that platform of having that first book to be able to give back to the community. So as part of doing that, all of my share of the royalties that would have gone to me for writing the book instead are going to Great Ladies. Great Ladies is an organization in the Groovy and Grails ecosystem that is specifically designed to help women get into technology, right? So they provide workshops. They use their own money that they get from sponsors to help bring women to conferences, to help bring workshops on nights and weekends when otherwise they might not be accessible. They're a fantastic organization, and their website is up there. Their Twitter information is on their website. I 100% encourage you to follow them and get clued into what they're doing, because it's really great stuff. So a rough agenda for what we're going to be talking about. I want to give everyone in the room a brief overview of what Ratpack is, how we build applications with Ratpack, sort of the basics, an introductory level thing. I'm not going to go into too much detail, but we are going to talk about it. I am going to do some live coding, so that's something that we'll get into. The second aspect that we'll talk about is something that is very unique to Ratpack. It's what makes it such a wonderful web framework and so much fun to work with and use, and that's its execution model. We'll go into exactly what that means. The third item that we will jump into is how this is all possible at all. We're talking about high-performance microservices with Ratpack and Spring Boot. Typically, you don't hear about two web frameworks interoperating with one another, at least at the kind of level that we're going to be talking about. We'll talk about the abstraction layer that makes that possible in the registry. And then, of course, demonstrate it with Spring specifically. Before we even get into what the high-performance numbers even look like, we'll do a quick demo, something that's very realistic. Hello World only gets you so far, right? And for a little bit of this talk, we're going to be talking about Hello World. We're going to be demonstrating Hello World. So by the end of it, you'll be very familiar with Hello World. But then I wanted everyone to be able to walk out of here with a practical example of how all this stuff ties together and what it means and what it looks like. So we'll jump right in. Quick overview of this. Ratpack is a high-throughput, non-blocking, asynchronous, reactive web framework for the JVM. That's a lot of words, right, that are going into this. Some of them seem very buzzy, right? They didn't always seem buzzy. It's probably not been until the last couple of years that these things are really starting to come to the forefront of our nomenclature as web developers, and that's an important thing to understand. We'll go into what some of this stuff means, but mostly through demonstration. So I think that should be good. Ratpack is built on Java 8, just right out of the gates. It is the first-class language for it. All of its core infrastructure, all of its modules, everything that happens inside of Ratpack is Java 8. Now, this might sound strange to some of you folks who have heard about Ratpack before, because you may have heard about it in the context of being a groovy web framework. Now, it's not a groovy web framework, and that's a point that I absolutely need to drive home. It has first-class support for Groovy, which is something entirely different, and that means that we're able to utilize the features of Groovy. We're able to leverage the aspects of Groovy's compiler to build this very nice and fluent DSL that I'll show to you in just a minute. But first and foremost, it's written for Java 8. You don't need Groovy. It never has to be a part of what you're doing. So if you don't like it, don't use it. The demonstration that we'll be showing. Now, just real quick, the purpose for this is so that there's no overhead. There's no language overhead, right? We want this web framework to be as performant as possible. We want to bring the most performance, the most efficiency, and that's why all the core is Java 8, right? In fact, the Groovy support, the decorations that exist for Groovy, to have that really nice DSL, they're all using parts of Groovy that make it so that it can continue to be high performance. But for the purposes of our example, we're mostly going to be speaking about about using it with Java. Are there any Java developers in the room? Just kidding. It's the whole room. Yeah, are there Groovy developers? There are a couple. Yes. I see you, Cameron. Fantastic. I personally really like Groovy. I'm really glad that we have the Groovy support. Groovy has come a real long way in terms of performance and efficiency over the years, and that's why we have it in Ratpack at all. But realistically, it works great with every JVM language. So if you hate Groovy and you love Kotlin, you can go for it. In fact, if you jump onto my GitHub, there are a couple of projects that use alternative languages with Ratpack. So this is really great. We integrate as much as possible. In terms of being a reactive web framework, almost all of the infrastructure of Ratpack is written as functional interfaces, which make it really easy to coerce to the various Lambda types that exist across every language, right? At the end of the day, every single programming language is basically the same, right? There are slight nuances here and there, but their internals are effectively the same. It wasn't a goal of Ratpack's right out of the gates to support every language. But just its nature as a reactive web framework means that it can do so very easily. The simple, and I want to stress, if anyone has any questions at any time, please just feel free, interrupt me, ask any questions, etc. So the simplest Ratpack web application looks like this. And this is Groovy, right? So using the Groovy DSL, it's very concise, it's very easy and very nice to work with. And we can get a very simple hello world out of this. And this is something that I'm going to demonstrate so that you believe me. So Groovy has this built-in dependency management system called grapes. And what we can do with that is we can add this @grab annotation to any script, and it's going to pull it down just like Gradle or Maven would. So we'll be able to add this into our class path. And then from here, we can just import the DSL for Groovy. And with just a few lines of code, we can build a hello world application. And we can go ahead and run it. We can see it gets up and running very, very quickly. Underneath the covers, Ratpack is using Netty. Netty is a non-blocking networking library. It's extremely fast. We don't have the kind of startup times that you might see with servlet-based web frameworks, right? That would be even today those have gotten fairly fast, but we're talking about the tens of seconds probably to get those applications up and running. Ratpack will start in milliseconds. It'll always start in milliseconds unless you tell it not to. And from here, just to prove it, we'll just do a simple curl, and you can see we got our hello world, right? Everyone can see that, I'm sure. It really doesn't get much easier than this to start writing applications. This is totally tweetable, by the way. I fit it in a tweet. It works great. Which, by the way, if you're not following me on Twitter, now is a fantastic time, because I am just very interesting. But again, using Groovy, that's good. It's got a really nice DSL. It's really easy to get applications up and running. You can start prototyping very quickly, spec out your API, see how everything looks, actually view it in a browser, all that stuff that you would normally do to get a project up and running. Likewise, though, the Java DSL really isn't very difficult to get started with either. And the equivalent of what we just saw, this is a completely runnable Java-based Ratpack application that'll do the hello world. The same API undersets both of these. So even though we're looking at it using Groovy and with closures, and we can drop some of the other things because we're informing the Groovy compiler that we're delegating to these different types. Looking at the Java example is a little more explicit, but it works exactly the same. Ratpack has no opinions about how you build your application whatsoever. There is no convention over configuration. There's no magic that sits underneath this. There's no class path scanning. There's no annotations, which will be very, very different for you Spring developers out there. Everything is extremely explicit, right? So you want to do something, you write it into the code. And what this buys us is basically the framework won't get in your way. If you have something to do, it gets out of your way very quickly, which is why when we're talking about bringing something like Spring Boot, which is in its own right, its own framework, into something like Ratpack and letting Ratpack do all the high performance HTTP work underneath that, it just works. And that's because there are no opinions in the framework. But we want to make common things as easy as possible to do. So just like you saw with the DSL, it's very concise, it's very short, very easy to get up and running. Likewise, when you have things like building component bindings and stuff like that, we want that to be one-liners as much as possible, right? And that is to say that everything is very explicit. So the first class concerns, the big things that we're trying to solve with Ratpack. So the big question that everyone always asks is why another web framework, right? There's so many that are out there. There are so many options. The big thing that we wanted to solve with Ratpack was performance. number one, first and foremost. Secondarily to that, developer experience. We want the development experience to be extremely nice, right? So as you're going through and building your applications and prototyping it, you should be able to make changes to them and see those reflected live, right? And I'll show you just real quick. So we still have our application up and running, right? And instead of, what I'm just going to do is I'm just going to tell this thing that we want to be in development mode. Whoops, sorry. So we're in development mode, right? And if I come back over here and do a curl again, you can see we have hello world. If I'm in the process of prototyping here, I can remove this, curl it again, and we will switch this over. Sorry, one sec. So we have our hello world application with the exclamation point. We just run it like a normal Groovy script. In this case, Groovy. We'll curl it, right? And then we will vi the app.groovy file, and we'll get rid of our exclamation point, right? Can everyone see this? You can't see the text? Here, sorry. Right. That should be a little better. We haven't shut down our application or anything like that. Our application's still running. We've gotten rid of the exclamation point, and you can see from this example, it automatically reloads the application for you. Wanted to make all of that as easy as possible. In the cases where we can't do hot reloading, restarting the application is designed to be as fast as possible, right? So the application can get back up and running through a full restart very quickly. And then as a final concern, packaging it, right? When we get into talking about things like microservices, you know, it can be very tedious to talk about packaging your application for shipment. How many people here are building fat jars, runnable fat jars with all your dependencies in them? How many people are deploying to like a Tomcat container separately, right, with war files? How many people here are building ear files? A couple, still, every year, still. But the number's getting less every year, so we're doing very good for ourselves. So I'm just going to make a new project. I'm going to use Gradle because that's the build system for grown-ups. And we'll just put some stuff in here. I'm just going to tell it I want to link to JCenter, which is the central repository for grown-ups. And I'm going to add this class path dependency to the build. This is adding it to the build, right? Not to our project at this point. Ratpack Gradle, let's do this. I'm just going to do this for simplicity, because I already have it downloaded, honestly. And I'm just going to say that I want to apply this Ratpack plugin. I want to use the Java one. If we were building a Groovy project, we would apply the Groovy one. And this is all that we need. And then we just need to tell it where to get its dependencies from. And then the Ratpack Gradle plugin is going to do all of the, add all the dependencies that we need into it. It's going to hook into all of the other plugins that it's incorporating so that it can provide that kind of first-class support for doing this packaging stuff. Now, we're going to do one more thing. We're going to add a main class name, and we're just going to say springone.app, right? Pretty similar to the way that modern Spring Boot applications are developed, right? Just with a main class provided as the entry point, et cetera. So we'll make a directory, source main Java SpringOne. And in this directory, we will have an app.java, right? This should look familiar to everyone at this point, right? I'm not completely going off the rails, right? So it's standard project structure, standard packaging structure, a simple Gradle build file. We'll start building our class, and we're going to say that we want to import the Ratpack server, and that lives in ratpack.server. And we want to define our class, which we've named app, and we want to say, we want to have a main method, right? So that this whole thing is runnable. And then from within our application, from within the main method, we're going to define the structure of the application. We're going to tell it that we want to go ahead and start. So we say ratpackserver.start. This takes a spec. The spec is what defines the structure of the application and how we're handling requests. Inside here, we have our handlers, which produces a chain. And inside this chain, we're going to have a get method, and then that gives us a context, and to that context we call render, and we say hello world. And now I'm aware of the fact that that I'm demonstrating things that we haven't talked about. Some of these things might seem a little bit different to you. We're not going to go too in-depth into that because we're going to be talking about very specifically building microservices that are very fast. But if you have any questions with this, feel free to come up and ask or interrupt me at any time. OK, so we have our app built, right? We have our simple hello world app built. We have our build.gradle all set up. Now we will use, I'm not quite cutting edge, but I'm pretty close, right? So we're just going to apply the Gradle wrapper because it's so much easier for us. And then once we have Gradle in our project, we'll just do a Gradle w build, and then we'll just tell it that we want to install dist. And what this is going to do is it's going to produce a directory structure complete with our application, all of our application's dependencies, everything that we need, including OS startup scripts into a directory, right? So this is done through the application plugin, sorry. And inside of our project directory, we have lib, which has all the dependencies that we need, or that our project needs, right? At this point, it's just Ratpack and its dependencies. We have a bin directory, which provides a shell script for Linux as well as Windows, if you're into that kind of thing, and then has all of the classes for our particular application, right? And it takes no more than just saying bin project. Ooh, it should take no more. Oh, did I do the package name wrong? SpringOne? Sorry? Oh, sorry. Okay, thank you. Today is my second day of programming, so got the package name wrong. So we'll do that one more time, and we'll jump over here, build install inside of our project, and then we'll just do bin project, right, to get this up and running. And address is already in use because we have our app running over here. But now what this becomes is basically a directory structure that gets wrapped up into a tarball, into a zip file that you can ship over to your server and install, and it comes with all the startup scripts, right? In addition to that, you can use the Gradle Shadow plugin. Who's familiar with the Gradle Shadow plugin? Cool. All right, one person. Great. So we'll show that real quick. Ratpack integrates with the Shadow plugin to, sorry, I'm just going to pull this out of one of my projects real quick because I always forget. To make fat jars, right? And so from here we can say com github John R. Engelman .shadow. And now we can just say Gradle W shadow jar. So this makes a fat jar that has all of the dependencies built into it. It's a very smart thing. The Ratpack Gradle plugin hooks into it to make this a very easy process. And now inside of our build directory, we have a dash all jar. And from here, we can just say right? So, so it becomes very easy. This is very similar to building fetchrs with Spring Boot, the way that the Spring Boot plugins for Gradle and Maven work, except this is significantly faster. That's important to note. OK, so those are all the first-class concerns. Performance, developer experience. We've seen the developer experience. We've seen packaging now. All this stuff becomes very easy when you're building Ratpack applications. We'll talk in a minute about performance. But before we even get to that, we need to talk about what makes Ratpack unique as an asynchronous, non-blocking, reactive web framework. Because there are quite a few of them out there already, right? And asynchronous in and of itself is obviously, it's not a new thing, right? This is something that has been around since the dawn of computers. Non-blocking even also is not a new thing. These are not new concepts. These are, in a lot of cases, these are solved problems. But the problem that we have with asynchronous programming, and the reason that we choose to take the synchronous approach that servlets give us, is that asynchronous programming is hard, right? Anybody who is not a proponent of async web frameworks is going to tell you just right away that you need to completely change your mind about the way that things work, right? And things are very difficult when you get into this way of doing things. But that's not the case with Ratpack. Though traditionally, it has been the case. It's not a lie. It's not wrong. The big problem with asynchronous programming is that you get, when you're invoking an asynchronous call that's probably non-blocking under the covers, there's this temporal disconnect between invoking the asynchronous function and getting back the response, right? So when you call it, if anyone here has ever written JavaScript, you guys already know what this problem looks like, right? Because you invoke the function, and then you provided a callback, and then at some point in the future, when that function decides that it's going to return, when it decides that it's done and it has a value for you, it's going to send that back. What this means is that bad things happen, right? So in this example, which is a wonderful example, though not terribly practical. We probably wouldn't do this in practice, right? But in this example, we are using a DB object to perform an asynchronous database call, right? We're passing off to that a product ID. You can kind of imagine what this interaction might look like. And then we provide to it a callback that will give us a product. And then we do something with that product. In this case, we want to add the product to this list of products. And then after that, if we were in a traditional way of thinking, like we do with servlets or like we do with Spring controllers, we can just execute all this stuff top-down, right? And by the time that we get to the end, we know that our products list is populated with all of our products, and we can safely send that back to the clients. But when we're invoking these things asynchronously, this is the argument against it. Because there's that temporal disconnect, when we invoke these functions, they immediately return and move on to the next thing. So even though we're adding the result of the first asynchronous DB call into that products list, then moving on to do the second one, we don't know when these things are going to return. So that first call, this may return first, or it may not, right? And especially if we're doing things like calling separate DBs or calling out to remote web services, which is a very common thing that we would do in a microservice architecture, we have no idea when what the sequence of these things is going to be. And so that means that by the time that we get down to sending the products back to our client, we have no idea what that product even looks like at that point, right? So the answer to this is to not do things asynchronously, right? No. This is the problem that we set out to solve with Ratpack. Ratpack's execution model provides deterministic processing of these asynchronous calls so that you have a contract, right? You have a guarantee as to what order these asynchronous calls will, number one, will be made in, and number two, when that data will be returned. And this is by way of the execution. So when we talk about the execution model, we're talking about a literal construct of something called an execution that sits underneath everything that you do in Ratpack. And this is roughly the equivalent construct to a continuation. And the problem is that on the JVM, we have no continuations, right? There is no native support for that. So unless you're using a Java agent to modify all of the underlying bytecode to make this work, which is not a great solution in my opinion, then we don't have a way to do that. And that's why the execution exists. In the context of an execution, which is everything that happens in a Ratpack web application, your application code can use a promise type to denote to the execution a frame, effectively, of that continuation, right? So you're given this promise type that you can do all of your synchronous or asynchronous work in to get this deterministic processing model that'll give you a guarantee as to when things are going to happen and when data is going to be returned and in different spots. We also refer to these often in the Ratpack world as execution segments, because effectively what we do is we break up all of your asynchronous and synchronous calls that are using this promise type into a different frame, and we execute those deterministically for you. So this is a little hard to see, but I'll zoom a little bit. So now that same call that we were making in the async example from before, consider it in the context of a Ratpack execution. This whole thing that we're looking at, all of this code, would be wrapped up into the idea of an execution. So all of these calls that we're making are doing so. And then these various calls that are using the promise type to perform asynchronous operations and eventually respond with the detail, these are delimiting the execution and informing the execution that they are expected to be executed in this order, and that the data from prior calls should be fully available by the time that we get down there. Now, in addition to providing you determinism in your asynchronous calls, which is extremely important for asynchronous web frameworks, asynchronous web applications, you also get some help with concurrency, right? We know that the first call and the second call are not going to return at the same time. They're not going to be adding to the list at the same time. We're guaranteed that that product's array list is going to be populated in the specific order that we have requested, right? Sorry, one more time? So the question was, what is the difference between doing things this way versus synchronously? And the answer is, we want to get it as close as possible to doing that, right? We want to get it as into a model that is very familiar and easy to work with, like synchronous programming. And the purpose for that is the networking layer that undersits this is non-blocking. We'll talk a little bit more about this in just a minute. But yeah, we want things to look and feel very familiar to the way that you're doing them, and to have the same kind of guarantees that you get with synchronous programming, but still be able to use that asynchronous layer on top of it. Because it's faster, basically, is what it boils down to. So the question was, how much does this parallel JavaScript's promise type? That was the first question. The first answer is roughly only in name. Probably the name promise was a bad choice, but it was something that was very familiar to people who are already familiar with asynchronous programming. But effectively, this is denoting to the execution, to the underlying continuation, that this specific block of processing is a frame in that execution, in that continuation, right? And once that is done, while we're waiting for a response to come back from this, and I believe I have a slide on this in the meanwhile, the continuation will be paused. There will be no processing on that thread. That thread can be returned to carry on with processing. The other thing to understand about Ratpack's promise type is that it doesn't eagerly make its asynchronous call. So it won't actually make the call, and this is part of it being reactive. It won't make the promise type is a reactive construct, very similar to, how many folks in the room use RxJava? Okay, a bunch, this is great. Very similar to the observable type, right, in RxJava. So the observable type you can pass around, you can do a lot of stuff with it, but it won't do anything until you actually subscribe to it. As opposed to in the JavaScript world, it'll actually make the call, it'll hold on to the value until you want it, right? Does that answer that question? Did I get to the second question? Oh, so the question was, what undersits this behind the scene? What undersits this behind the scene is a mixture of callbacks, futures, and other streams is the right answer to that. Yeah.
I have no experience with Ratpack, but just wonder why do you decide to use functions like classes with type methods instead of like having conventions from the ASYNC context or something? Because this way it makes for people like me a lot harder to use the API.
Yeah.
Like if you have a spec that has your context and everything that you may want something on top of it.
Yeah. Yeah, great question. So the question was basically why do you choose to use these static methods as opposed to adding them as methods onto something like the context or something like that? And the answer for that is that an execution on a managed thread can take place at any point, and it's not necessarily always going to be wrapped in the context of that. Sorry, it's not. The wording gets very overloaded here. It's not always, that code is not always going to be executed with necessarily access to that context object. So I'll show you a very quick demonstration here. So say that we have our Ratpack application, and we import, just doing the Groovy DSL again, just because it's a little bit easier to get it up and running. So I have my handler chain, and I have a get handler on here, and normally here I just render hello world, right? And in here, this is equivalent of having the context object. So the question then was, instead of saying promise dot async, right? Go off and do some async work, and then subscribe to it and get back the value. Why not just do, sorry. Let's say it like this. Why not just do ctx.async, right? And so the answer to this is we're on a managed thread. Ratpack manages all of the threads that exist in effectively in your basically in your application, in the thread pool that your application starts up with. Which means that if we have a method here, void foo, and we want to do something that involves some asynchronous work that we want Ratpack to know about. In other words, we want to delimit. We want to say that we're producing an asynchronous frame to the execution that sits underneath it, but we don't have any access to that context object, right? So the only other way that we can do that is to give it this promise type and say that we're going to go off and do some asynchronous work, and then we're going to get that data back out of it, right? So this can happen at any point. So from within this method, I can just say foo, and we'll be able to, we get all the benefits of the execution model without having to have access to that context object. For the execution. Yeah. Yeah. No, you're 100% right. This is really a convenience method for being able to do that. So basically, you always know that if you're working with promise types, you'll be able to delimit the frame there, right? And this is especially important when we're designing APIs, that are going to return something like a promise type out of it. When we make that call to foo to get back the promise for a product type, we know that it's going to go off and do an asynchronous call. But from within that foo method, it's being responsible for delimiting the frame, right? So it's very, I would actually say it's somewhat infrequent that you would actually do that stuff yourself, as opposed to working with a library from the framework that has that capability of doing that. And a perfect example of that is Ratpack's HTTP client. It returns a promise for you, so you don't necessarily have to do that yourself. So those segments, like I said, they're always guaranteed to execute in the order that they were given. Now, in terms of performance, Ratpack maintains a small thread pool for its processing, right? In a typical servlet-based application, you have a thread per request, or maybe you have a thread per connection, which means that if one instance of your application gets 5,000 clients that connect to it, at best you're going to have 5,000 threads that spool up, right? It gets no better than that. In a Ratpack application, let's say that you're starting on a server that has 4 cores that sit behind it, right? Your Ratpack application is only going to maintain 8 threads in total. And what that gives us the ability to do is fully maximize your system resources for when those requests come in. And because there's a non-blocking networking layer that sits underneath all of this, we can continue to handle the processing of new clients as your Ratpack application is off performing its asynchronous work behind the scenes, right? As an execution segment is being processed, its thread is then able to be returned to the pool to handle subsequent calls. So while you're waiting on that asynchronous database call to return the product value from the product database, while that call is being made, that thread is able to be returned to the pool and handle new clients and handle additional processing that's going on. And this means that we can take on a hell of a lot more work and not exhaust your system resources by standing up things like threads. These are persistent things. They're set on a high priority thread pool right out of the gates. And that's very important. But the question is, why is that important? And the answer is, as we move increasingly to the cloud and into cloud computing, basically what this boils down to is every little bit of system resources that you use, you pay for, right? So the more bang that we can give you for your buck means that you can spend less money on server infrastructure while being able to handle a much bigger workload, right? So in practical terms, using something like Ratpack is going to actually end up saving you money in the long run because it's going to fully utilize those systems that you have for it, right? I also just want to point out that because Ratpack is a reactive web framework, we also have integration with the most popular of reactive libraries. So if you're familiar with using RxJava, you never even need to know about the promise type. You can continue to use observables exactly in the way that you would. And what Ratpack does is it provides a scheduler to RxJava so that anytime that you're using an observable in the context of your application, it'll know that that observable is the effective equivalent of a promise type, and it'll know to delimit the execution according to whatever you're doing inside of that observable work. So you get that guaranteed determinism in your asynchronous work without having to change your coding style at all. Ratpack also provides an implementation of reactive streams. Its own implementation, which is very good. You can get extremely far just by using the core Ratpack libraries. Registries. We're running a little behind, so I'm going to go a little bit quicker. Registries are effectively an abstraction over dependency injection. And this is a really important thing in Ratpack because effectively registries, basically within any of your Ratpack applications, you can get away with using no dependency injection framework, and you can just provide your own component bindings. It's the basic component binding infrastructure. You can get away with using one, something like Google Juice, which Ratpack provides native support for right out of the gates. Or additionally, Ratpack also provides support for Spring Boot right out of the gates. So you can use all 3 of these ways of performing your component bindings in the context of your application without them ever overlapping one another, which is how what we're going to demonstrate today all works at all. Because we can just throw Spring in there and tell it, hey, now Spring is the registry. But in reality, it can be any dependency injection framework. So if you work at one of the wonderful companies like I have in the past that built their own DI system 15 years ago before DI systems existed, and they just never got rid of it, then you can put a Ratpack registry on top of that to tell it to pull component bindings from your custom DI infrastructure and have it just work. And all of this just works because you're going to be using the registry APIs for pulling component bindings out. This also means that you can get started very quickly with no DI framework, and then when you're ready, you can get into adding Spring into your project, right? So real quick, this is a demonstration of what a registry looks like in Ratpack. As part of your server specification, you tell it what the structure of your registry looks like. Inside of that registry, you apply your component bindings. Now this is done entirely without any DI system behind the scenes, right? So all that we're doing is we're putting an object into the registry, and then later on inside of our request handler, we're able to pull it back out of that registry by using the get method on the context object that comes out. So you can do all that until you're ready. And then when you're ready, you can throw Spring Boot in there and have it just work, right? You don't need to change any of the code that you use to pull that binding out in your handler. And you can do all of this using the programming conventions that you're already familiar with and already comfortable with being Spring developers, right? So in this example, we have a main class, right? And we've annotated it with Spring Boot application. And we probably, all of you know, if you don't already know, that at Spring Boot application annotation adds all the magic sauce that makes Spring Boot work and fantastic and just great, right? And then we provide a bean definition inside of that class, which is going to return the myasync DB service that we had just very explicitly bound in the last example. And then from our handler chain, prior to that, we set up a registry using this convenience method that's provided as part of Ratpack's integration with Spring Boot to tell it that we want to transform the Spring application context from our configuration class into a Ratpack registry. That work was done by Dave Sire, so it's very good. You can know and then when we're inside of our request handler, then we can pull it back out exactly as we would have done otherwise, right? So in effect, it doesn't matter what sits behind it. You can use all of the programming conventions for binding your components in the way that you're already familiar with and the ways that you already like, and then just pull it out using this registry API. There's no, to answer your question, so the question was, is there an annotation to make it easier? No, there's no annotation. Ratpack is explicit where it needs to be, and this is one of those areas. Yep. Sure.
I started to get a little bit in the woods, a little lost. I kind of asked Lawson for some help and got a little bit from the guys. But what are some of the high-level things you would recommend for somebody who's not real good with reactive and understanding back pressure and brains and things of this nature? How do they make it work without getting in the woods real quick?
Yeah. So the question was, reactive programming gets really hard really quick. That's 100% true, especially when you need to do the more complex stream processing, stuff like that. The question was, what are some good resources for doing this? So selfishly, there's an entire chapter in my book on reactive programming. In addition to that, there's also an entire chapter in learning Ratpack on Ratpack's execution model, talking about all this stuff. There's an O'Reilly book in the works right now for RxJava. And they're making very, very good progress on it. I would definitely recommend buying that. It's early release right now, but it just continues to get better. Some other stuff, the RxJava wiki page in their GitHub repo in the REACTIVE-X organization on GitHub, in there, they just have phenomenal documentation. And it's got all the marble diagrams that show you exactly what's going on when you're using any of the operators off of that. But yeah, that's what I would say. Yeah. So Yeah, so as you continue, so you already know Spring Boot, right? And there are so many things that you already like about it. You can continue to do that while using Ratpack under the hood for high throughput, right? So if you like Spring's configuration model, which I really do, I love Spring's configuration model. It just works, which is amazing, right? And with a couple of annotations, a little bit of magic behind the scenes, and voila, you can map a YAML file very easily onto an object in your application, and you can use it throughout your application for doing everything that you need to. We're going to jump off to the microservice example, because in there, that's specifically what I do. So, so basically, in this application, I have pretty much exactly what I've just shown you. The names have changed a little bit. Can everyone see this, the code? OK. So we have a Spring Boot application class, which is our main class. We have a main method. We'll talk a little bit about the RxJava stuff in a minute. We're effectively using the Spring Boot integration with Ratpack, just as I demonstrated a minute ago, to transform that Spring application context into a Ratpack registry. And then we're defining the structure of our application. We attach a simple get handler here that's going to use this product service to go and get a list of products and then send it back as JSON to the caller, right? So a couple of things happen in here. If you are not, again, already familiar with @Spring Boot application, this is effectively the magic sauce that that does a lot of stuff, right? It'll component scan your class path. It'll automatically discover bindings, where things need to be. It's a configuration, so we can use that as a source to create an application context, et cetera, et cetera. And this does a lot of work in the background for us, right? So one of the things that we're doing in this particular application is I have a component in my application that's a configuration properties, annotated with configuration properties. This is semi-terrible what I'm doing, extending hash map. I wouldn't necessarily recommend it, but basically what it's going to do is it's going to map our configuration from an application.yaml file, where we define some stuff about what our database connection is going to look like, onto an object that we can use throughout our application, right? And we do that here in our bean definition. So effectively, what this microservice is going to do is it's standing up an HTTP application using Ratpack, and then all of the Spring stuff behind the scenes is where we're going to bind all of our components. We're going to use its configuration model to pull everything together. And this application is going to make a call to Postgres. And I'm using an asynchronous Postgres library for Java to stand up a pool and connection. And I have a product service that is going to use that Postgres connection pool. Query for rows, I'm just doing a select star from product. It's a very small data set. Don't be concerned about that. This particular library uses RxJava behind the scenes. So our service class, our product service class in this case, is going to return observable, right? But that's OK, because in our application, like I said, Ratpack integrates with RxJava very nicely. So we can use this rxratpack.promise method to transform that observable type into a Ratpack promise and subscribe to it to get the list of products that came back out of that method. So there's a little bit of extra work that's going on behind the scenes here to make it so that you remember how I said that Ratpack uses Netty under the covers, right? So basically, I would say these days just about every asynchronous library for the JVM that's doing any kind of things like database calls or stuff like that is going to use Netty. This one happens to as well. I've done a little bit of work as part of this to make sure that basically that we're going to share the same event loop between our Ratpack application and this particular library's way of making these calls. So it's not going to stand up an additional thread pool behind the scenes to do all this stuff. Oh, sorry, I was showing you the wrong class. Yeah, so we're going to share that event loop group between Ratpack and this particular library so that we're fully utilizing the system resources. We're not spawning up additional thread pools that we're not going to use, et cetera, et cetera. And if we fire up this application, we'll see, the things that you like, right? You get the Spring Boot banner, all the stuff that Spring is doing, and then our Ratpack application has started, right? And it is our Ratpack application that is accepting traffic. And if we come back over to our terminal, and we tell it that we want to curl localhost, right? Because I attached that request handler just as a regular get. I didn't give it a path or anything like that. So it's going to handle that request, and then it's going to go off and do that select star that we looked at, and then it's going to transform that into a product model object, right, and send it back to us. Then we can see that we get back these two records, right? Two records that I put into the database. Is very simple. Just to demonstrate that it's actually making that call behind the scenes, and it's actually working, and it's using Spring to do all of the magic sauce here, right? So when we're binding our product service, for example, you may have noted that as part of our application, we don't have any explicit bean definition for our product service, right? We're just leveraging the fact that Spring will do all of that auto-wiring magic behind the scenes, and we can pull it out of our Ratpack registry that's backed by Spring exactly as we normally would, even if it had been an explicit binding. But our product service is actually annotated with the service stereotype, right? So it got picked up automatically, and all this stuff just works, which is great. This is how these two things live together. This code is on GitHub, so you can check it out. You can look at it. All that kind of stuff. All right. Let's talk about performance numbers, right? Because this is the big kicker to the whole thing. Is this being a practical demonstration? It's making a database call, right? It's standing up configuration. It's doing all the kind of stuff that you might do in a microservice. We need to actually look at what some of those performance numbers look like so that you can understand why Ratpack is effectively a good choice for doing this kind of stuff. But before we do that, I want to have a real quick tirade on performance testing, all right? Generalizing performance testing for all use cases is absolutely impossible, right? So anytime that you see any kind of performance numbers, any kind of analysis of what a web framework's performance is going to look like, it absolutely will not apply to your use case, right? They should be used as a guide, not the word of law. So take that with the spirit of what we're talking about. I ran these performance numbers based off of this specific application under different scenarios. It's not to say that other optimizations couldn't take place. It's not even to say that in different scenarios that you wouldn't get completely different numbers. It is strictly to say that on fresh systems that are running in the cloud, this application was started, connected to a database that was not on localhost, actually lives somewhere persistent, and a load test was thrown against it. And the next logical thing that folks who are really into performance testing will tell you is that you shouldn't test in the cloud, or on the cloud in this case. And they say that because there are a lot of factors that go into cloud computing, right? And there's a lot of stuff that sits behind that stuff. Specifically with respect to how CPU and memory resources are delegated out to these underlying systems. None of that matters because honestly, this is where you're going to run, right? You're going to run in the cloud. So I'm not interested in giving you numbers of what this Ratpack application will look like on bare metal. I'm more interested in giving you numbers of what it'll look like if you actually were to go and take the same steps to start it up on for example, Amazon Web Services, right? So very, very unrealistic. We can't talk about not testing in the cloud because that's just a reality. That's the way that we operate these days. So we need to think about it in that. And it's not it's also not going to be about how much traffic can be sustained for any period of time, because no reasonable system administrator, for whatever they are called these days, is going to tell you that your application should be running at a sustained 100% maximum throughput all the time, right? The answer is, how much burst traffic can we take at any given point in time while making sure that the service doesn't fall over, right? And to give us enough time to horizontally scale. This is a reality of the way that computing works these days, is really, we just need our service to be able to take enough traffic so that we can recognize that we're taking a hell of a lot of traffic and auto-scale those servers out so that we can add more in. The amount of traffic going to any individual instance will reduce, and then when the traffic numbers slow down, we scale it back in. So let's get to it. Not that. All right. All right, so these were real numbers that I ran off of the latest version of Ratpack. I want to emphasize I didn't do any server tuning or configuration or anything like that. Again, we're looking at how much traffic we can handle at any given time for a period of time in a way such that we would be able to satisfy a number of clients for a period of time before we can auto-scale, et cetera. So all of these were run on AWS, on EC2. Effectively, trial number 1 was against the T2 microtype. The instance type that was holding the database behind the scenes was also a T2 microtype. The thing that I want to stress about this is that this is the free tier. This literally costs you nothing. And we were able to achieve, with that application, a sustained throughput for over a minute of 9,529 requests per second. The second test was on an instance class above. How many folks run on AWS here? Okay, a bunch. So these instance types, this makes sense to a lot of people, right? So these are fairly standard, very common things that I'm choosing. T2 medium, which is a step above. I did not increase the database size because the database wasn't yet maxed out on its own. It looked like it could handle a little bit more load. So we kept that the same, 10,259 requests per second. Trial number 3 was with both of them as T2 mediums, just out of curiosity to see if I could push it a little bit further. 17,000, almost 400 requests per second throughput. Trial 4 was on an M4 instance type, keeping that T2 medium behind the scenes. This was actually recorded a little bit lower, which shouldn't be surprising because Amazon's M4 instance type is memory intensive. In its nature, Ratpack is not memory bound, it's CPU bound. So the more CPUs, the more CPU compute resources that it has, the faster it'll go. Trial 5 was on one of its compute classes, was a little bit surprising to me on a C4 large. At this point, I still had not maxed out the capabilities of the database, so I kept that on a T2 medium. 15,000 roughly requests per second. Number 6, I did upgrade the database type just to see if it would help. It did wind up helping, probably for different reasons, but nonetheless, ran the test, and 16,000, just over 16,000 requests per second. And then finally, on a C4X large type, with that same T2 large database type behind, 23,149 requests per second. All of this is to, you should understand that all of these tests were run on a single instance of Ratpack. This was not run on multiple instances behind a load balancer. One of the cool things I saw about this type, which is really probably cooler for Amazon than for me, but the C4X large instance type actually went from a cold JVM, a cold startup of the JVM, to from 0 requests per second to 20,000 requests per second in under a minute with absolutely no problem. Didn't break a sweat. which was pretty great to see. And as a result of that, I was able to increase the number of persistent connections and squeeze a little bit more out of it from there. So these numbers are available. You can see exactly what the app looks like on my GitHub in this S1P high-perf microservices repository. Yeah. So the question was, have I done the same test with a synchronous call as opposed to an asynchronous one? Do you mean in Ratpack or with? I mean, do you mean as a Ratpack application? Okay. So because of the way that Ratpack works, where it maintains a very small number of threads that manage all of the processing for your entire application, you should never do blocking work on any of those threads. So anytime that we need to do blocking work, we need to schedule it out to a different thread pool. Ratpack has a very easy mechanism of doing that using a blocking promise type, where it'll send it over to an IO-bound thread pool where it can do that work behind the scenes. I haven't run it. I'm sure it wouldn't look as good because basically you're going to be doing a thread per request, right? And that's not really what we want to see, right? So some future possibilities here. Spring 5 is going to be reactive, right? If my understanding is correct at this point, also the web MVC layer as it exists today will be decoupled from the servlet API. So this will give us the possibility to potentially in the future integrate Spring controllers on top of Ratpack, where Ratpack is handling all of the underlying HTTP connections. You get all the benefits of its execution model and asynchronous abilities, but using Spring controllers on top of it. That'll be kind of nice. Underneath Spring 5 sits Project Reactor, right? Which is a fantastic, just wonderful reactive programming library that's been done by the Pivotal folks. This effectively has two types that represent the way that your reactive data will be returned. A flex, which is multiple objects coming back to you in your stream, or a mono. We potentially in the future will be able to provide a scheduler from Ratpack's execution model over to the Project Reactor execution so that we can map those flex and monotypes over to promises and delimit the execution accordingly. Very similar to the way that we work with RxJava, as we showed. All right, that's what I got. Questions? Yeah?
How does Spring Security interact with Ratpack and like other testing support and last of all like red dots?
Yeah. Yeah, so the question was, how does Spring Security integrate with Ratpack? The answer is, at this point, not at all. Spring Security is pretty heavily reliant on servlet filters and the servlet API. The second question was testing support, right, in Ratpack. Testing support it's one of those things I wouldn't be able to squeeze into a talk like this, but there are extremely good test fixtures. Ratpack.io, if you look in the manual, it's got very good coverage of that stuff. And the third question was REST docs, right? And in the Ratpack organization on GitHub, there's this project called Example Books. Example Books is, basically a proof of concept, just showing basically all the capabilities that we have. Jen Strader, who runs Great Ladies, provided a pull request for us that uses Spring REST docs behind the scenes. When you're doing functional testing of your Ratpack application, it'll auto-generate those ASCII documents for you. That stuff is available. I was trying to find the classes that she used. Base documentation spec. Oops. So inside here, if you look at this, it's got a, oh, sorry, everything that extends this class. You can look at, and it shows exactly how to do that stuff. Spring REST docs are rad, by the way. Yeah.
To follow up on this question about the, using string data, and you had mentioned a thread manager. Is there one that works best? Are we talking like Okta or something different?
Sorry, say it one more time, I'm sorry.
With making your database connection,
Yeah.
is there a specific thread manager that you would suggest for that?
Thread manager?
Something like Okta, you had said that you wouldn't want to do those stateful requests.
Yeah, so you want, basically you want anything that is going to use Netty under the covers, right? So that you can share that event loop group between your Ratpack application and that library to make these non-blocking networking calls behind the scenes. Does that make sense?
Yeah, just looking at moving forward and upgrading full services or calls.
Sure. Yeah, we can talk about that. I think we have to finish up. If you have any questions, please come on up, and happy to answer them. Thanks for coming.